Buried nearly 200 miles beneath the far side of the moon, in a region no human eye has ever directly seen, there is something enormous sitting underground that nobody can fully explain. Scientists have measured its effect. They know roughly how much it weighs. They know almost exactly where it sits. What they don't know with any real certainty is what it actually is. One of the researchers who found it described it in the simplest, most striking terms he could manage, comparing it to taking a pile of metal 5 times larger than the entire island of Hawaii and burying it directly under the lunar surface. That's not science fiction. That's a real, published, peer-reviewed description of something genuinely sitting beneath the moon's far side, discovered using NASA's own gravity mapping spacecraft. This is the real story of the mysterious mass anomaly beneath the moon's South Pole Aitken Basin, based on actual research conducted using data from NASA's Grail mission, and I want to be upfront about something before we go further. This isn't breaking news from this week. The core discovery was first published back in 2019, with additional refinement and follow-up research continuing in the years since, but it remains one of the strangest, least understood features anywhere on the moon, and most people have simply never heard about it, which makes it exactly the kind of story worth properly explaining. Every figure, quote, and detail in this video comes directly from the actual published research and statements from the scientists who conducted it. Not speculation, not exaggeration, just an honest account of one of the stranger mysteries sitting quietly beneath our own closest neighbor in space. Let's start with where this mass actually sits, because the location itself is a genuinely significant part of the story. The South Pole Aitken Basin is the single largest confirmed impact crater anywhere in our entire solar system, stretching roughly 1,550 miles across, nearly a quarter of the moon's total diameter, and reaching depths of up to 5 miles in places, deep enough to swallow Mount Everest with room to spare. It formed approximately 4 billion years ago, when a massive object, likely an asteroid or a similarly sized fragment of early solar system debris, slammed into the moon with enough force to blast out a crater large enough to swallow entire countries several times over, releasing an amount of energy almost impossible to properly convey in ordinary terms, enough to melt and reshape a significant portion of the moon's outer layers in the immediate aftermath of the impact. Unlike most of the moon's more famous, more easily visible features, ones like the Sea of Tranquility where the Apollo 11 astronauts first landed, the South Pole Aitken Basin sits almost entirely on the lunar far side, the hemisphere permanently turned away from Earth due to the moon's tidally locked rotation, hidden from direct view for the entire history of human civilization until spacecraft finally photographed it during the 20th century. Because it's the oldest, largest impact site on the moon, scientists have long treated the South Pole Aitken Basin as an extraordinarily valuable natural laboratory, a place specifically well-suited for studying the kind of enormous, catastrophic impacts that shaped every rocky planet and moon in the early solar system, including our own Earth. Peter James, a planetary scientist at Baylor University who led the research team behind this discovery, has described the basin in exactly those terms, calling it one of the best natural laboratories available anywhere for studying catastrophic impact events, an ancient process that fundamentally shaped every rocky world we see today, including the ground beneath our own feet. The actual discovery came from combining 2 separate sources of NASA data. The first was gravity field information gathered by GRAIL, short for Gravity Recovery and Interior Laboratory, a pair of NASA spacecraft launched in September of 2011 specifically to map the moon's gravitational field in extraordinary detail, part of NASA's Discovery program and managed by the agency's Jet Propulsion Laboratory, with the mission's principal investigator, Maria Zuber, based at the Massachusetts Institute of Technology. GRAIL worked by flying 2 identical spacecraft, nicknamed Ebb and Flow, in a coordinated orbit around the moon, precisely measuring the tiny changes in distance between them as they passed over regions of stronger or weaker gravity, since even small variations in underground mass distribution subtly affect a spacecraft's orbital path, causing it to speed up almost imperceptibly over denser regions and slow down slightly over less dense ones. Over the course of their roughly year-long mission, which concluded with a deliberate, controlled crash into the lunar surface in December of 2012, the twin GRAIL spacecraft produced the most detailed gravity map of any planetary body beyond Earth ever assembled at the time. The second data source was detailed surface topography gathered by NASA's Lunar Reconnaissance Orbiter, using an instrument called the Lunar Orbiter Laser Altimeter, giving researchers a precise, high-resolution map of the basin's actual surface shape and elevation, accurate down to a remarkably fine scale. By combining these 2 datasets, refining previous calculations for the thickness of the basin's crust and the density of the underlying mantle, researchers uncovered something genuinely unexpected: an enormous, unexplained excess of mass sitting roughly 180 miles beneath the basin's floor. Here's how James himself described the sheer scale of what they'd actually found, in language that's stuck with people ever since this research was first published. "Imagine," he said, "taking a pile of metal 5 times larger than the big island of Hawaii and burying it directly underground. That's roughly the amount of unexpected mass researchers detected sitting beneath the South Pole Aitken Basin. To put the Big Island's actual size in perspective, it covers more than 4,000 square miles on its own, meaning the anomaly researchers found represents an absolutely staggering quantity of extra material, hidden entirely out of sight, with no obvious surface feature directly announcing its presence. And that's exactly what makes this discovery so genuinely strange. The excess mass isn't visible from the surface at all. There's no crater, no mountain, no obvious surface marker directly announcing that something this massive is sitting underground. But its gravitational influence is real and measurable, and it turns out to be doing something subtle but genuinely observable to the landscape directly above it. Researchers found a distinct oval-shaped depression on the basin's floor, sitting roughly half a mile lower than the surrounding terrain, a feature scientists call the central depression. That depression appears to be a direct physical consequence of the buried mass's own gravity, quite literally tugging the surface above it downward, warping the landscape from nearly 200 miles below without ever breaking through to the surface in any other visible way. The lunar equivalent of a heavy object placed underneath a stretched sheet, creating a gentle, sagging dip in the fabric directly above it without ever actually poking through. To really appreciate how strange this actually is, it helps to imagine standing directly on the surface above this buried mass. You wouldn't see anything unusual at first glance. No metallic surface poking through, no obviously different rock formation, nothing that would immediately tip off an observer standing there that something this enormous was sitting almost 200 miles beneath their feet. The only clue, visible only through careful, precise measurement rather than casual observation, would be that subtle, broad depression in the landscape and the equally subtle, equally invisible tug on any spacecraft passing directly overhead. Daniel Moriarty, a lunar geologist at NASA's Goddard Space Flight Center who wasn't directly involved in leading the study but reviewed its findings, described the significance of this discovery in genuinely enthusiastic terms, calling it a huge result, and explaining that it offers real, direct insight into what's actually happening deep inside the moon's interior, information that's otherwise extraordinarily difficult to obtain through any other method. Brandon Johnson, a planetary scientist at Purdue University who studies impact events and also wasn't part of the original research team, described his own reaction in similarly excited terms, noting that, as someone who specifically models impact events for a living, this kind of finding is exactly the sort of result that gets a researcher genuinely eager to dig into the data further. So what actually is this mysterious mass? Researchers have proposed what remains the leading, most scientifically plausible explanation. Though it's important to understand, this remains a strong hypothesis rather than a fully confirmed, settled fact. The most likely explanation connects directly back to the same ancient impact that originally created the South Pole Aitken Basin 4 billion years ago. When a large asteroid or similar object collides with a planetary body at the kind of extreme velocity involved in an impact this size, often tens of thousands of miles per hour, the impacting object itself doesn't simply vanish or bounce away. Depending on the specific dynamics of the collision, the angle of impact, the relative composition and density of the impactor compared to its target, a portion of the impactor's own material, particularly its dense metallic core, can potentially become embedded directly within the target body, essentially fusing with the planet or moon it struck rather than being entirely vaporized or ejected back into space. Under this scenario, the mysterious mass sitting beneath the South Pole Aitken Basin could represent literal remnants of the original impactor's metallic core, a genuine physical fragment of whatever object created this crater in the first place, still sitting embedded deep within the moon's mantle 4 billion years after the actual collision occurred, a genuine piece of another world entirely, delivered by violent accident and preserved ever since. It's worth being clear about exactly how confident scientists actually are in that specific explanation, because the honest answer involves real, acknowledged uncertainty. James himself, in describing the initial findings, was careful to note that the exact reason for the anomaly's existence remains genuinely unclear, even while the metallic core hypothesis stands as the team's leading working theory. There are competing explanations that researchers have also had to seriously consider and weigh against the evidence. One alternative possibility involves the buried mass representing an unusually dense concentration of crystallized minerals called oxides, formed through an entirely different process, one connected to how the enormous ocean of molten rock created by the original impact might have gradually cooled and solidified over time, with denser minerals sinking toward the bottom of that cooling magma ocean and gradually settling into a concentrated layer. Both explanations remain scientifically plausible based on the currently available evidence, and distinguishing between them with real confidence will likely require additional research, potentially including future missions, specifically designed to study the region in greater detail. There's a broader reason this specific mystery matters beyond simple lunar curiosity, one that connects directly back to questions about our own planet's history. Earth experienced its own share of enormous ancient impacts during the same violent period of solar system history that created the Moon's South Pole Aitken Basin, a chapter of solar system history scientists sometimes refer to as the Late Heavy Bombardment, when the inner solar system was subjected to a dramatically higher rate of large impacts than it experiences today. But our planet's active geology, its shifting tectonic plates, its erosion, its volcanic activity, has long since erased almost all direct physical evidence of those ancient collisions, continuously recycling and reshaping its own crust over billions of years in a way that has essentially wiped its own early impact record clean. The Moon, lacking that same kind of active, ongoing geological weathering, has instead preserved a genuine, largely undisturbed record of impacts stretching back billions of years, essentially functioning as a natural time capsule for exactly the kind of catastrophic events that also shaped early Earth, but that our own planet's dynamic surface has long since erased. Studying a feature like this buried mass gives scientists a genuine physical window into that ancient, otherwise inaccessible chapter of solar system history one Earth itself can no longer directly show us. In a very real sense, the Moon's far side has been quietly keeping records our own planet was never able to hold on to, and every new piece of that record scientists managed to properly read, whether through gravity mapping, surface imaging, or eventually direct sample collection, adds another small piece to our understanding of exactly what the early solar system was actually like back before Earth's own surface had settled into anything resembling its familiar modern form. This particular mystery also connects to a broader pattern of gravitational anomalies scientists have identified across the Moon using Grail's detailed mapping data, features astronomers generally call mass concentrations, or maskins for short. These maskins were actually first noticed decades earlier, back in the 1960s, during NASA's original planning for the Apollo missions, when engineers noticed unexpected, unexplained variations in spacecraft orbits caused by concentrated pockets of extra mass scattered across the lunar surface and interior. Jay Malash, a geophysicist at Purdue University who led a separate 2013 study specifically focused on solving the broader Mascon mystery, described exactly how disruptive these anomalies were for the engineers planning humanity's first crewed lunar landings. Mascons, he explained, were nothing more than navigational hazards when they were first discovered, genuine obstacles that Apollo-era mission planners had to carefully identify and route around, much like reefs scattered across an otherwise open ocean without any clear, confirmed scientific explanation available at the time for what was actually causing them. For decades, these mascons functioned mostly as navigational hazards, obstacles Apollo-era mission planners simply had to account for and route around, without any clear, confirmed explanation for what was actually causing them. It wasn't until Grail's detailed modern gravity mapping data became available decades later that scientists finally developed a considerably clearer picture of how these mass concentrations actually form, generally tied to the same basic combination of ancient impacts and the subsequent cooling and settling of molten rock that may also explain the specific anomaly beneath the South Pole Aitken Basin. Malash's own research specifically studied two particular basins, using this improved data, one on the lunar near side and one on the far side, developing sophisticated computer models to understand exactly how a concentrated pocket of extra mass could form and persist for billions of years following a major impact event. Work that laid important groundwork for the more specific, more extreme discovery beneath the South Pole Aitken Basin that came several years later. It's worth appreciating just how much of this particular mystery still remains genuinely open, even years after the initial discovery was first published. Researchers involved in this line of work have indicated plans to continue studying the South Pole Aitken Basin in greater detail, refining their models, and searching for additional evidence that could eventually help distinguish more confidently between the competing metallic core and crystallized mineral explanations. Given renewed international interest in returning to the Moon, including NASA's own Artemis program and various robotic missions planned by multiple space agencies, specifically targeting the lunar South Pole region, an area of increasing interest, partly because of suspected water ice deposits and permanently shadowed craters nearby, there's real growing potential for future missions to eventually gather additional, more direct evidence about exactly what's actually sitting beneath this ancient, mysterious basin. It's genuinely worth imagining what a future mission specifically designed to investigate this anomaly directly might actually look like. Unlike the broad, sweeping gravity measurements Grail was able to gather from orbit, a dedicated surface mission, whether a rover, a lander equipped with sensitive seismic instruments, or even eventually a crewed expedition as part of a more mature Artemis program, could potentially gather far more localized, detailed data about the exact composition and structure of the South Pole Aitken Basin's crust and upper mantle. Seismometers placed directly on the surface, for instance, could potentially detect telltale signatures in how seismic waves from natural moonquakes or deliberate impacts travel through the region, offering genuine, direct physical evidence about whether the buried mass is dense, metallic material consistent with an ancient impactor's core, or something closer to a concentrated layer of crystallized minerals instead. That kind of direct, ground-based investigation remains largely aspirational for now, but it represents exactly the kind of follow-up work scientists in this field have, specifically identified as the clearest path toward finally resolving this lingering, genuinely open question. So here's what I actually want you to take away from all of this. Nearly 200 miles beneath the far side of the moon, hidden entirely from direct view, sits an enormous, genuinely unexplained mass, roughly equivalent to a pile of metal 5 times larger than the big island of Hawaii, quietly warping the landscape directly above it into a distinct, measurable depression. Scientists have a strong, scientifically grounded leading theory about what it likely is. Quite possibly the buried metallic remnant of the very asteroid that carved out the largest impact crater in our entire solar system 4 billion years ago. But the honest, complete answer remains genuinely unresolved, an active area of real, ongoing scientific investigation rather than a fully settled, closed case. That's not a disappointing conclusion. It's actually a genuinely exciting one, a reminder that even something as extensively studied and as close to home as our own moon still has real, substantial mysteries buried within it, quite literally, waiting for the right combination of data, technology, and patient scientific curiosity to finally bring them fully to light. We've sent astronauts to walk on the moon's near side. We've mapped its gravity field in extraordinary detail from orbit. We've studied its surface, its craters, and its composition for well over half a century, using tools ranging from simple handheld cameras to some of the most sophisticated planetary science instruments ever built. And despite all of that accumulated knowledge, there's still something enormous sitting quietly beneath its far side that nobody can fully, confidently explain. A genuine reminder that proximity and familiarity don't automatically translate into complete understanding, even for the single closest celestial body to our own planet. If you want to know what future lunar missions eventually reveal about this mysterious buried mass, subscribe and turn on notifications. Because renewed interest in exploring the moon's South Pole region could bring us considerably closer to finally settling this specific question. And drop a comment telling me which explanation you find more convincing, a genuine buried asteroid core or a dense layer of crystallized minerals left over from an ancient cooling ocean of molten rock. Because honestly, after digging into this research, I think either answer would be a genuinely remarkable thing to finally confirm.